Here is just a quick example from our textbook dealing with a quadratic function. This one involves price, quantity, and revenue. So if you have your e-text available, or you can look here, we're on page 135, and the problem that I'm going to look at here is just problem 26, revenue. The Better Baby Buggy Company has just come out with a new model, the Turbo. The market research department predicts that the demand equation for turbos is given by Q is equal to negative 2P plus 320, where Q is the number of buggies it can sell in a month if the price is P dollars per buggy. At what price should it sell the buggies to get the largest revenue? What is the largest monthly revenue? Okay, there's a couple of things I want you to think about here. First of all, if you focus just on these two columns, those columns are basically the information that's given to us directly in the problem. I've just set up what I consider a reasonable domain for price for right now. I've started with a price at 0, and for the time being I've gone up to a price of $200. In the next column for Q, that is simply where I've typed in my formula for quantity. Negative 2 times, reference my cell A3, plus 320. That formula I've dragged down. This formula, the revenue formula, is going to be the thing that if I asked you to write it down on a piece of paper, you would be telling me revenue is equal to price times quantity. Just like in that earlier example with the sunglasses, we were looking at $22 per pair. Well, here, the information is not as discrete. We have P dollars as our price, we have Q as our quantity. So in order to write the revenue function, we would write it in terms of our independent variable P. So R of P would be equal to P times, make sure you put your parentheses there, negative 2P plus 320, where this negative 2P plus 320 is our quantity and P represents our price. If we do that, when we come into Excel, we don't really have to rewrite our formula in Excel. Remember, the beauty of Excel is that we can just use cell references. So here, you're not going to see me retype out that formula that I may have written on my paper. In Excel, I will simply use the cell reference of price times quantity. Okay, when I double-click that down, you can see what happens to the revenue. It looks like certainly the revenue increases for a period of time, but then if we start selling the buggies for more than a certain amount of money, unfortunately what happens is our revenue goes down greatly. So with that in mind, let's go ahead and do some graphing and see what we have. If you highlight all three columns and insert a scatter plot, everyone, what you're going to get there is two data series, okay? And I want you to think about what those data series are. We basically want to use this revenue data series only. You can right-click on the blue. Those represent just your quantity, and you can basically delete those. When you delete those values, then you can see that if these in fact represent the quantity going across here, we can see our quadratic function start to take shape. Okay, so we've got some things that we want to consider there. With our quadratic function, we know that algebraically we could find the vertex or the maximum value simply by using the formula x is equal to negative b over 2a. We'll talk more about that in another lesson. Right here, what we know that we could do is if we look, it appears that up until a price of $100, we can continue to see that the revenues are increasing. So what I want to do is right here in Excel at row 6, I'm going to insert, and what happens is I will insert a row above. So what I might want to do there is type in a value for price. So suppose I type in a value of $150. At $150, I can see that the revenue is lower than it was at a price of $100. So this is kind of a really good way to start looking at some of the things in Excel and how you could manipulate your values. So perhaps I type in 120. How does that change things? Well, even at a price of 120, my revenues have gone down. So as I continue to approach 100 from prices above it, maybe now I'm going to try 110. Well, at 110, you can see what happens. At 110, I've got, still a smaller revenue, but it's looking like right around 100, I might be approaching my maximum. So what happens next is probably I'm going to go in a little bit closer. I've inserted another. I'm going to go right at a price of $101. See what happens here. And again, we can see that a price of $101 takes it lower than that other value of $12,000 that we saw before. Let's go on the other side of 100, and on the other side of 100, let's type in $99. Sometimes these cells for you might be auto-filling in, and wow, look what happens there. All of a sudden we get a value that's greater than that value that had shown up all throughout the problem of 12,000. Now we've got a revenue of 12,078. So at that point, what do you want to do? Now what you want to do is you want to inspect perhaps the other side of 99. So let's go to maybe 90. Let's see what happens at 90. And look at that. There we have our maximum value so far for revenue when we set our price at 90. You could continue inserting here. I'm going to do one more for the sake of it, and then we're going to go into just evaluating the vertex. But suppose I type in now $80. At a price of $80, we would sell 160, and the revenues would be $12,800. So it certainly looks like we're getting closer to that maximum value for revenue. What I want you to do for a second now is you can continue to look at the spreadsheet, play with it a little bit, manipulate it, and see if you can close in on that value. Remember, we're looking at that kind of limiting value as we approach, from the right and from the left. But the other thing that I want to do here is I want you to think about this concept. The vertex, and in this case a maximum, occurs at x is equal to negative b over 2a. So if you think about what that is, all of you have had other sorts of pre-calculus or algebra classes. So when you think about your vertex in this case, we're thinking about this function, this r of p. Well, what we have to do with that is we do have to think about that function in terms of its expanded representation. So what I mean there is basically I want to think about that in terms of r of p is equal to, multiply that out. So that would be negative 2p squared, I'll change that in just a minute, plus 320p. And what I mean by that is, if you have it written in that format, you would be able to look at that and immediately recognize that the value of in that quadratic, we would know that A is equal to -2, B is equal to 320, C is equal to 0. Remember, they're the coefficients in our quadratic function. So if we're trying to evaluate -b over 2a, when you think about what that would be in terms of the representation for this, wouldn't it make sense that x is equal to, well, -b, or the opposite of b, would be -320 divided by 2a, which would be -2 times 2. When I reduce that, I'm looking at -320 divided by -4, which in fact is +80. When x is 80, we reach our maximum revenue. Well, here we did it by trial and error, but we did find that value. What I would want you to do now is, just for the sake of it, go ahead back in, insert one more row above, let's say at 70. And at 70, you're going to see that the revenue is lower than it was at 80. Now, I know this video took a little bit of time, but I wanted you to think through some of the basic things with quadratic functions. I hope this helps.